Hi everyone.
Hello, sir.
Yes, we wait for some time. There are few candidates are not there. Only the four are there. They
Okay,
are
no problem, sir.
okay. They will come in 5 minutes. We wait for the
Mm-hmm.
5 minutes only. Okay.
Yes, sir. Yes, sir.
Thanks, Suman. Oh, what do I- Okay, it's now okay. And we see the histogram of this is like this, and the box plot if we see, we are getting in this way. So, and we know that it is now normal 0.34. It is less than 0.5. So what we do, we don't use this. Okay, so just make it comment, and we'll find out the upper limit of RC, and it would be the mean of for the upper limit. Use the plus 3 into SD and dollar. So this we are getting. I will show you. How much is it? It is 46.02. Okay. And we see how many are there. So I have taken the RC and I will see. So there are 19. Okay. So I adjust them and I will show you again. There is no. On the lower side, we also see, because it is showing me that there is lower side may be possible some outliers over there. Or we also check it the value of lower LL underscore RC, and we just copy and paste it, and I just change the sign. Instead of plus, I will use the minus here. Here I will use the minus sign, and I run it. And I copy up to here and paste it here. And what I do, I will take the LLRC. How many? But here are smaller than. And I see there is nothing. So I don't need to do this. I have no requirement of this. So I just comment it. Now there is next column is the FICO. You know that the FICO, I will tell you about the FICO. This FICO column. We have taken these and monthly income, debt to income ratio, interest rate, amount requested. These all we have taken the control, the outliers. Now I see the histogram of this. So I think there is no, there are few. And I see the skewness is what? The skewness is it is positive, skewed. Lean hop is there or not? And it is positive skewed, so I will take the quantile first, and I'm getting this quantile. So I'm taking 732 plus 1.5, 732 minus 682. So it's okay. I see how many are there now. 9 are there, so I will do it. And then I see the skewness is 0.75, which was previously I think that 0.77. It reduced a little bit because we have adjusted it. And now I show you this and we were doing yesterday this model fitting. Okay, so I just run it. I will not see the plot, and I will like to see that 0.58 is there. And highest is this one. If you look at this, yesterday we skipped some step. For the FICO, I think we have skipped yesterday. FICO, we have not considered yesterday, I think.
No, sir, we did not do it.
Yes. So our yesterday algorithm was changing. You know that. So here you will see we will get the right one here. Here debt to income ratio and house rent is this much. So we have to deduct the debt to income ratio we have to put first. So yesterday
Sir,
we had,
yesterday you told us that we have to take the VFS value first.
oh.
First, out the
Yes. We have not taken the VF value. Na? Okay, I have not taken here. Sorry. It is the this one, house rent mortgage. Correct. Everything is controlled. Now we see this. So here we see 0.62 and then 0.67 house owner. Okay, 0.67 we are taking. Point 0.61, 0.31. So 0.61 I consider debt to income ratio. Next. Okay, it's correct. And I see it now. There is rent. So I consider this also. Now everything is in our control. We are not reviewing this one. Dots are there. That is little bit how very boundary. It is on the boundary of that. And this formula I have explained you yesterday. Up to here we have covered.
Yes, sir.
Yesterday we have covered up to here. Now one I will use one GG plot figure.
sir, model fitting, you were explaining that red line that comes.
That is the tuning we will see later on.
Okay, sir. Okay.
You have created the model. If you want to see the summary of model, is the final fit is the summary of model. Right? Final summary.
Yes, sir.
This is our summary of model. Okay.
Yes, sir.
This is the formula
Now,
we have. These are the residuals statistics. These are the beta 0, beta 1, beta 2, beta 3.
so yes, you explained this.
Got it?
Yes, sir.
These are we use in our equation. I explain you how we create the equation. In the back end, that equation works. Okay.
Okay, sir.
So I will show you how we get it. We have a target variable, what? Interest rate. Okay. Or you know that our general equation is what? Y cap beta 0, beta 1 x1, beta 2 x2. And this way we take it.
Yes, sir.
Beta k xk. K variables we are taking. Y variable is our interest rate. Got it? So Y cap
Yes, sir.
would be the interest rate.
Interest rate.
Beta 0 is this one. Got it?
Hmm.
So that is 7
Yes, sir.
point. I just write the 2 decimal places up to. Got it?
Yes, sir.
And then beta 1 is this one.
Yes, sir.
So I'm writing the
1.7.
1.79 into 10 to the power minus
Minus.
4. It is E for 10.
Hmm.
and multiplied by amount requested. AR I am writing here.
Yes, sir.
So whatever the amount requested value you will feed, that will multiply with this coefficient,
Okay.
then it will add on this equation. Got it?
Okay. Okay.
Second is the minus. So plus minus is minus.
Yes, sir.
So I will get the minus sign here.
Hmm.
And
Eight.
2.86 into 10 to the power minus 1. And it is
Okay,
multiplied
sir.
by monthly income.
Monthly MI.
Got it? In this
Okay,
way,
sir.
we complete this equation, or it is our predicted. This interest rate is
Predict.
predicted. That is a Y cape. Got it?
Okay. Okay. Yes, sir.
Any doubt, anyone? Any
No,
question?
sir. So in the upper cons you've written a formula and then you written fit. What is the meaning of that?
What? I could not. Please, pardon, please.
In the
Yes.
upper in the source you have after this you have written formula and within brackets you've written fit. What does that mean?
Formula fit. It just gives us which variable we have included there. It will not give us this complete formula, this complete equation. Got? So equation will work this way. Got it? I will show you. I will create that equation
Yes.
separately. I will show you how to create that equation later on. Okay. Backend, this equation works. Clear? Now
Yes, sir.
I want to predict with the trend data itself. We have created the model with trend data. Okay. Understand? On VC, if I put the trend data in my model, how does it predict? Correct? I have an actual prediction also there in the trend data. Got it? I have the Y value there. Interest rate is already there. Or I want some predicted rate over there. So function is predict. Here we write the model name first. Model name is fit. Got it? Then comma new data. What data you are feeding for prediction. So I'm feeding first the training data. Then I will use that test data later on. Okay. And I run it. So I will get this prediction. Oh, I have this much. So I will show you the head of this prediction. Head of actual interest rate I will show you first. Okay. So LD underscore trend dollar interest rate. These are the actual interest rate. What we have. Got it? Now I will show you the head of this predicted. You see, this is the actual interest rate and our model predicted this one. This is the observation number. The first observation was 975 indexing. Then 7210. We have selected randomly, no? Partition the data randomly. So it is showing me that indexing also. But you compare this. The first actual is 13.48 and our model predict 12.36. Second is 17.17. Our model predict this. It is 15.81. Our model predict this. This is 10.65. Our model predict this. This is 17.27. Our model predict this. This is 14.09. Our model predict this. Got it? I explain one more thing you could better understand. This is our y, or this is our y cape. Got it? So what we get? The error y minus y cap epsilon. So it is y is 13.48 minus 12.36. Is it clear? That is the E1.
Yes, sir.
Then we get the E2. E2 is 17.77 minus 16.06. I am just writing the 2 digits only, not taking the round off and that whole thing. E3 15.81 minus 15.04. Okay. And then I get the summation of this EI. Is it clear to all?
Yes, sir.
And how we measure it, and that is the later we will process that. But here you see this difference is not much. Okay, it is very near to that. Getting it? It is doesn't mean that somewhere you have the 6 and it is telling 17. Sorry, not like that. Okay, our line is best fit. The actual number, this is our predicted line. These all points are lie here on this line. Got it? Y cap. And these are the points lie. The line is the point is greater than this lie here. Then this point lie here. They're smaller than. So the actual point is greater than will lie above that. And 15 point, this will also lie here. And then 10.65 and they are 11 points. So it will lie here. Got it? Yes.
Sir, can you show us that indexation part? I mean, how we can find out those points in entire data set? Can you
That
help
is the
us?
975. It is the actual indexing. We could
Okay,
not find here. We could not find here at this moment.
okay,
Now we have to use some technique for that.
okay,
It is the first in this data frame. In this data frame LD underscore 10, it is the first one. Okay.
okay.
I show you that. I just write on the console.
Yes.
Oh, sorry. I just run this again, so it will not disturb us. I just run this again too. And then I run here. Got it?
Okay, okay,
Okay. But it is a 975 observation from the actual data before partition.
okay. Fine, sir.
Why we don't remove this from our data set? You understand now? ID.
Yes.
This is the actual indexing. This is the actual indexing. It keep inside it, not the ID. It is the actual indexing of the data. Okay.
Mm. Okay, okay.
From 1 it starts, and then we have taken it. Now I will show you how our model is work. So I have make this graph in the ggplot2, and it gives us good idea. You see what I have done here. I explain you. LD train data we have. Okay. In that LD train data, I have mutate one column, new column, that is the predict interest rate. Because previously I have done separate vector. This prediction and this prediction is same. Understand? You see this formula and this formula. Is there any difference?
No, sir.
So this we have created independent predict underscore trend. That is our independent. It was not included in my data frame. Got it? Now I have muted one column. I have muted one column, a new, that name is predict underscore IR, and the same formula I'm using here. And I'm getting this column there. And then I'm making a ggplot with aesthetic. On the x-axis, I'm putting the interest rate, actual interest rate. On the y-axis, I am putting the predicted interest rate. Got it? Is there any doubt?
No,
And then
sir.
I am making a scatter plot geom underscore point, and alpha is the size of these points. I could reduce the size, and you will see this alpha is the opacity, not the size. It is the opacity. Opacity means the transparency of that. Got it? Okay. So why I have figured it out? Because I see if my interest rate is increasing in my actual data, the predicted interest rate is also increasing, both in the same direction, positive correlated. Got it? Nikita,
Yes, sir.
got it?
Yes, sir. Yes, sir. Yes, sir.
So this gives us some idea how our model is going on. It is working in the right direction or not. Okay. So in the predicted interest rate and the actual interest rate, there is positive correlation. It means our model is in right direction. Correct? What Aditya?
Understood, sir.
Okay.
Yeah.
So that I have prepared only for this purpose. We could see the direction is right or wrong. Okay. Now I explained this thing to you already, so I'm not explaining it. I will show you the in fit. There are many things in our model. Uh, Names fit. I will show you how many attributes are there. So these are the attributes we have: the coefficients, the residuals, and facts and rank, fitted values, assign, QR, df dot residual, x labels, call, terms, model. This is all we get here. But I will show you how we could create that. I tried to create one equation of the model, but it will not. It we could not use it. Alpha value is only for the opacity. You could change the opacity, transparency of that. So I just show you. Don't go in deep in this. How I created this, I will just show you that. Hmm. You see, this is my model equation. This is the beta 0. This is the beta 1 x1, beta 2 x2, beta 3 x3. I am getting in this way. Okay. Correct. I just tried to make one equation. You could show someone. Okay. Now I will show you some graphs. I am making the MF row, margin of figure by row. I will make 4 graphs in one. Okay. In one plot. So this I am setting. And I first show you the plot fit. Got it? So this is my first plot, residual versus fitted and normal key Q C location, and these all I am getting in the one. I could make it separately if I use the default parameter, and I will write in this way for the plot which equal to 1. So I will get this one, then 2 I will get next one, then I will get this, then I will get this. Or here you see we are getting this all. Okay. But I have taken these IDs.
Sir, maybe you might be searching for those 3 points which were showing on
Yes, I know
residual.
that. I know that. I have taken the ID of that.
Yeah.
Through the indexing, I have selected the ID. I have got that ID, and then I put here. Okay, those IDs, which I don't want to include in my data frame. These IDs I want to remove. Okay, so how I got that 1587? If I show you, so I just see LD underscore 10. It's a task. Just run this and see. Column selected and define column selected. Not, it is not a column. It is a row. Oh no, it's something else. It is not giving me that.
Sir, the ID showing in the graph is the ID or index, sir?
It's a indexing through the our this particular. If I see the 1587 is showing me this, and this the 29283. Oh, we have not mentioned it here. I just see it. What is this?
Maybe, sir, you will have to search in fit table instead of LD train.
Hmm. Just a moment. I see it. Hmm. It is the Cook's distance 15871. It is showing me. It is 500. We have 17. It is
Sir,
below. Hmm.
x-axis is observation number. So can we identify based on that?
Hmm.
Can you zoom this graph, Cook's distance? So these are the observation numbers, right?
Yes. On the x-axis we have
So it is near to 400.
something.
Yeah.
That I am also guessing it. Uh, just a moment, I will see. The different graph will show me the actual one. We don't have that, no? We have 150 something. And 1587. Just a moment. I think what I have done later on, how I get it, I will just show you. I calculated this and I calculated in a console basically previously. I see that 161151 ID here. Uh, just a moment. Got it, got it. It is not the indexing of our this data frame. Basically, it is the indexing of the this indexing is from the our training data set, but we have got the indexing, the old indexing we have got over there, and that we partition it. Okay, that indexing is there. So 1587.
Sir, I think you can sort that particular column. I guess there is a small arrow above that. If that works out, then it can sort the indexation, I guess. Oh, it is not happening.
It will not work then.
Okay.
I have searched with some technique. I know that, but I am forgetting it. Okay, okay. I tell how I get it. It's the 1587. It is the indexing of this. Mhm. Okay, I do one thing. I do one thing. Correct. I got the point. And just go there. And right. Correct. Is it clear? We have to use the quotes here. Sorry, I forget to use it earlier. Okay.
Why, sir?
Because we are getting here indexing of the total data set. Okay. And we want the
Before splitting main
before
and
splitting, that indexing we are getting in our data set.
okay.
So when I have to use the indexing of this data set, what we have the partition already. So I will write that indexing in quotes. Okay. So I will show you that it is a between before 400 or before 500 something. Okay. So in the ID, if I show you that 61154, I will search it. I'll not run the next line. Why it is so? That I write in this way. Then see. So all columns I want to see. Correct number of dimensions. Just a moment. I want to think on this, then later on this one. Correct number of dimensions. Equal to we have to mention there. Not working. It is in that one. The 611151 1587. Okay. It is giving me that 1587, and if I write the 376, 97462. Correct. We are getting correct. Okay. These are the customer ID. And if I filter that customer ID, I could filter it. I use the dplyr function, so it would be better. The R basic, sometimes the codes are little bit confusing. And I just filter it. So I use the filter function. I don't use that. I don't want to use it in my data. LD train and pipe 2. Then I filter it and filter ID equal to 97462. I am writing this. I'll see what result I get. Oh, I'm getting this only. I'm not getting that particular.
Sir, I have shared the code in chat box, sir. You tried, sir.
I tried. Okay. This we have used earlier. I used it. Once more I tried. I used it. Our base code, I used it. Let me see. Okay. It is not giving me the actual indexing of that. No? I want this actual indexing, the which number is it? This we are getting through that also. No? So we see that we could select it. I try to select it. We could find it out if I write in a search and I write that number, that index. I write this index 61151. 61151. Not 61151. So this is my 1587, and it is not showing me which actual index is here. Okay, it is the previous indexing, but here it is like below 500. Correct? Got it? So we could not see that. It is below 500. That's not a task we have to perform, but I will just want to see that. What I am doing now, I am removing these IDs from my data frame, training data set, because these are the outliers. Got it? Is it correct? So I remove this. So you see how many are there? 7747, and I run this. I'm getting 1744 now. Is it clear? I run this model again. After removing this, I will train the model again. I just train the model again. The debt to income ratio, first we use the VIF. Okay. So I run the VIF and I got house mortgage, correct? And then I see the okay, summary. I think every there will be no difference, much more difference will not be over there. House ownership, little maybe. House ownership, correct. And I will show you the summary. Then house ownership, we are getting 0.41 debt to income ratio. So that is the debt to income ratio. And then we see the summary. Then we are getting this, it should increase this. So we could next time we get that 0.41 house rent. House rent. And I will get that, must be there. So there is 0.41 house rent. I have taken house. Okay, I have not taken that summary after house rent. I have to see that summary. And you will see now it is 10. This also we have to remove now. Okay. You improve the model little bit. LP underscore DC, we have to remove this also. That is 0.10. So LP underscore DC will remove. Just copy it and paste here and run. Sorry, it's always creates a problem. Let us see. Now everything is in my control. Oh, now I see that graphs plots now. I will just show you all plots together, or we see separately. Okay. There are now some other outliers we are getting. This. Okay, so in this way, we will remove one by one. We could do it. But in practice, we don't remove these outliers when we create a model. We use some other techniques. This is one of the techniques. Either you could remove the outliers or you could use some other techniques. So this is the one way for tuning the model. As per the model, whatever the outliers you are getting in the model, it will take very long time. It creates some new outlier, then you have to remove them, then it will create some new. So it take very long time. Or it's a Cook's distance formula we are using there. If you read on the internet, you will see how does it work. And we have some other options. Okay, what we use, I will show you. Now, I just doing one thing only. One thing I am doing here, but just I am removing this NPDC and okay, I do it. Then I will see it later. We have to run from starting. Just a moment. I will show you that graph which I want to show you now. I am making a data frame with fit residuals. We have the various names I shown you in the in the feed. So there is a residuals, and I will show you that data frame. So it is the residuals, and I'm making one a density curve for that. So it is the residual, the density is given. So it is the actual, or this is the normal. Green is the normal. And we could see the normality test for the residual. Okay. And this is the normality test. It is very, very low. less than 0.05. So it is normal. Our residual is normal. If it's less than 0.05, so it is normal. And we find out the mean RMAC for this. So RMAC, we are taking the data LD trend prediction, and we are taking the prediction for test data also, and then we measuring both RMAC. In the, if we predict the training data, so there is a RMAC is 1.95. If we predict the uh, test data, which is separate data I'm using in the prediction, and how much RMAC, it is not giving me the RMAC. Why it is not giving me the RMAC? You know that. Why? Yes.
We didn't test the data, sir.
Yes. What? Yeah. Hmm. Please pardon. Uh, we are using this test data in our model, and I want the prediction from the unknown data. Why it is giving me NA? Aditya, why it is giving me NA? Yes.
I will have to figure out.
Okay, Nikita, can you explain me why it is not giving me the mean RMAC for the test data?
No idea, sir.
Because we have processed the data after partition. Got it? Some part of data we have processed after partition of the data. So we have processed the trend data only. We have not processed the test data. Understand?
Okay, sir. Okay, sir.
Okay. Okay.
Got it? So the same process after partition we have to use for test data also. Got it?
Yes, sir.
What process? I will show you. Just a moment. Yes. And at this moment, we should be very careful when we, this you see, after partition, what we have done? We have filled the missing value. Okay. And that missing value have filled with this 3. Got it? So
we have to do the process again.
no, for the all, no. We don't have to do the all process again. Somewhere we have to put that data, uh, test data only on the some point. Okay. I will explain you where we could do it. In the test data, we will not impute the missing values. Understand? Got it? Yes.
Yes, sir.
If you have the data, complete data, then we will find out the prediction only. Okay. So this missing is not, we have to bother about the missing. Okay. Got it? So for outliers, what we have to do? We have to use only here in this line. Got it? Not this process. I will show you. Mhm. Just a moment. Why this key is stuck always? Okay. What I have to do? This whole process I have done through the training data. Okay. I will not do it again. I will just do, I will change here only where I impute the value. Okay. So what data name we have? LD underscore test or LD only test? LD underscore test. So I will just write here test. Got it? And here also. And here also. Okay. Outlier I have fixed with that at the during modeling with the test data, trend data. Now I just change in the test data as per the outlier, whatever the value is greater than the outlier which we have computed earlier, it should be converted in the that. Okay, it's okay. That is very important. What we have to pass through that uh, process. I run it. This I have done. Next, I will see what I have to do. Next, also I have to put here uh, where there is no need. I think that it was interest rate was not having any that. So wherever I have, I will just write on here. Okay, got it? Clear? Any doubt? Yes. And these outliers we have done.
So one question.
Yes.
So basically, in test model, we so basic from the beginning we partitioned the data,
Yes.
and we ran a training model,
Hmm.
and in that we checked for VIF, and we tuned the model, checked for outliers, and
Hmm.
after everything we got the prediction of interest rate.
Yeah. Yeah.
Now, if I remember correctly, you told us that we use that prediction and we kind of check it with the test data. If it
Test
is
data. Yes, correct.
right. So now in test data, you are again, because after the partition, these changes were made in the data.
Hmm.
So in the test data, you're also making the same changes.
Yes.
If
Yes.
it is the outlier, at least treating the outliers.
Yes. Yes.
Now, will we also do the VIF or something in this, or
No. 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 The model is
nothing like
already
that?
fitted. You have to
Okay,
pass the data through the model now.
okay, okay.
Okay.
Yeah.
So I just try again. I think that it should work now. It's not giving me up to when I have to process the data, then I could get it. I will show you this data. Here we have taken this all. The pre-processing before partition is okay. There is no problem. And the after partition, we have to do that. Okay. After partition, we have done that. We have to do that only. Okay. And we could see that how many NAs are there. First, we see due to NA, it may be possible. Okay. So I will just see some. Is dot NA in LD underscore test. And we see 32 NAs are there. So we remove the NA and then we try. And but before that, we have to pre-process that. And we are not pre-processing it because it will not affect our prediction, or not. It will not affect the. It will give us the prediction because if it is only we have worked with the outlier, we have not done any feature engineering over there. Rather than that, is it clear? Because all the dummy variables we have created before, so it will give us little bit different. It may be little bit ups and down in the that, but try to do that. So what I am doing here with the test data, I am doing one process. Here I write that LD underscore test, LD underscore test. What function I will use for omit these values? All the NS.
Omit dot na.
NA dot omits, I think.
Sorry, na dot.
Okay. Blank, keep it blank. And now I will show you that again. How many NAs are there? So there is no NA. And now I see. It will work, I think. It should work. It is giving me. Okay. It is giving me.
And what is the RMSE of the trained data, sir?
It is very, you see, difference. Very big difference.
Yeah, what does this mean, sir?
It means that we have to pre-process our data again. And the test data we have not pre-processed totally.
Okay.
Got it? So we have to pre-process that data. Then we see what is that. Okay. You could do this thing yourself. I have shared this script to you all. If you want today, I also share so you could get the new code.
Sir, I still didn't get any email of link. You didn't. I don't have
Okay.
the.
Oh, sorry. I will share today. Okay. I will share
Okay.
today
Okay.
because so we can do it yourself. You try and tomorrow I will do it again. Okay.
Okay.
And tomorrow we see some more thing about it.
So, sir, that means we'll have to impute the missing values in a test dataset as well, right?
No. There is no need. We have removed dot variables, what dot observation in the test data.
But if we would have
Suppose
imputed,
what I want to say that Aditya, you have created one portal for this form.
right,
Okay. And here, where you will enter the single entry of the single observation entry. Got it?
hmm,
You will enter the whatever the variables we have in this model final. If you see the final we have, I will show you the final variables we have here. These variables we have, it will be mentioned in the form.
right,
amount requested, monthly income. So you have to fill all the variables.
Right.
If you skip anyone, you have uploaded this form in some portal or some mobile app. Then if you skip something, that it should be filled with that missing algorithm. No. These are the required, we could say, the variables. There must be the entry of this all. If you are missing any value, then you could not get the correct prediction. That we used for our model purpose. Understand? We have imputed the value for making the model because we don't want to lose the data if we have so many missing values.
Okay. Okay.
So why we have used that technique there, but in the test data we will not use it.
Okay. Okay.
Got it?
Right. Right.
So we for the outlier, that is compulsory, because it will be in our calculation now. If something is very high, because you know that we have taken one, we have changed the scale also. Cube root scale we have taken.
Yes. And
Nikita, we have taken one cube root scale.
Yes, sir.
So why we are getting this much value?
One log scale also we have taken, I think. Sir.
Yes, yes.
So what we will do is we will process the training data again.
No,
And
the
then,
test data.
no?
We will process
Okay.
only the few points.
Okay.
Not the all. As I mentioned, you one, na?
Yeah.
Only that final. The calculation we will not use there. Okay. The
Okay.
finally where we have impute that.
Okay.
This is the imputation. If else.
So all the imputations that we did, we have to do in the test data.
Test data also.
Like one log scale, one cube root,
Yes,
and
yes.
okay.
Yes, yes.
Also, one question, sir. I mean, when you ran the regression model in the training data,
Hmm.
you removed some variables for a better forecast because they were not significant.
Yes, yes.
So, but then in test data, those variables are also there.
Hmm.
So, I
It will
mean,
not consider, na?
okay, okay,
Variables are there, but it will not take.
okay. So it will take only the variables that are
Which
model.
are is significant in the model, in the final fit model, the variables. It will take the values only for those variables.
Okay. And
Okay.
So
the purpose of both the RMSE coming near to each other would be that I mean, if the RMSE would have been very close to each other, one could say that
Yes.
our prediction is good and it
Good.
is close to the test data.
Yes, yes.
Okay, right now we haven't really got a good prediction. That's what we can say.
Yes, yes.
Okay,
Got it?
yes.
So
sir,
that is the
in
very
the
important thing. Yes, yes. Ishita, ask what you are asking.
sir, like you said, we have to replace all the LD train with test in all of these, and then we'll get the RMSE value lesser.
Yeah,
Or we
not
have to
replace. We are just also pre-processing the test data. Okay, just
yes, sir.
copy it.
So only these statements, the if else statements only.
Yes, yes, yes. Okay.
Okay, sir. Okay. Before that, we don't
This
have
and
to.
one more, that the log we have taken na, somewhere, and
Yes, the log and cube root.
yeah. That is we have to take. Okay, we have changed the scale. Na?
Okay, so we have to do that similarly only.
You write here before this prediction, before measuring that here you write those code here. Okay,
Okay.
here
Okay.
somewhere you write here one comment you write, and comment that the pre-processing test data.
Okay, sir.
Okay, pre-processing test data, and you then copy paste here
All
and change
the
the
statements.
data frame name Okay.
Okay, sir.
So you could bifurcate it, what we have taken, what we have done. Is
Okay,
it
sir.
clear?
Yes, sir. Yes.
So what we do, whenever we make a model, then we deploy it on a internet. Okay. So we deploy the process also. So this pre-processing, whatever the syntax we deploy there. Got it? Not all the calculations. Only the pre-processing, what you will type here, it will be deployed there in the backend of that. So first the data, whatever you enter, it pass through it. Okay. And it get, and then it go to the model. Got it?
Sir, and what should be the minimal difference between the RMSE values of the two, so that we can say that our prediction is correct?
It near about 20%.
20%. Okay,
Yes.
sir.
Okay. Whatever the value, it should be 20% plus minus. Correct? Sometimes it may
Yes, sir.
be less than training data also, RMAC. Sometimes. It depends on the testing data. No? What sort of testing data do you have? Correct? So
Sir,
I
in
will
this,
try to complete this tomorrow, and I will show you. I will save the data, and then we read the data from there itself. Okay?
sir, will we also do heteroscedasticity and autocorrelation, something
Yes,
checks?
yes, yes. I will explain you that thing. VIF is also used for the heteroscedasticity. You know that?
But that's mostly for multicollinearity.
Yes, yes.
Heteroscedasticity and autocorrelation are a little different.
Oh, sorry,
Sir,
sorry. Yes, 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 yes. That is for the multicollinearity VIF we are using. And
yeah.
I will tell you later on these all things. I have in PPT it was there. No? I have mentioned
Sir,
it.
and what about the ANOVA model, ANOVA synthesis?
ANOVA was in the R2. Later we will, it was in the R2. This is the R3 basically.
Yes, sir. Okay.
Sir, so like, how much have we covered in this module till now?
We have covered more than 80%.
But logistic regression and something called regularization, I think, is there, no?
But it will not take much time because
Okay,
the whatever the processing, the pre-processing I have explained you here.
okay,
There would be 2 or 3 new things you have to learn only. The other script I will run.
okay.
As you have seen, I have to explain each and every step here.
Yeah,
Okay,
yeah.
there is no need to explain each and every step. Few steps I will run directly. We are doing this thing. We are converting in the numeric,
Mm-hmm.
and the few I have to use for that.
Okay.
So it will
And
not take the 3 or 4 days.
okay.
It will be
And
finished in one day only. The logistic.
okay, okay.
The first
And
model take time, na?
yeah, 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 of course.
Yes.
And sir, we will also do PCA in the end.
PCA we will cover it.
Sir,
I will.
please send the link today. I don't have any of the material or anything.
No, no. I will send you. I will send you.
Yeah.
Don't worry. I will show you that.
So tomorrow we'll discuss this as well. If our test, the RMSE values, if they don't come to the provided value, then we can discuss this as well.
Yeah, yeah. We will discuss this whole thing. And you see the assumptions, the 4 key assumptions we are taking for this, the need to test the linear regression model. Linearity is there, independence and the homoscedasticity. Okay. And the normality. Uh, so I have explained this whole thing. Normality, how we cover everything. Why we are taking the variance of the residual increases, the variance increases. So I will explain this whole thing. I have not explained it previous because I just want to show you how to create it. And then we see these parameters. Okay. Without these assumptions, we could not create a model. But I have not explained these assumptions first. So after doing it, then I will explain these all things in a detail. Correct? It is everything is there in my PPT, but yes, I will send you the code again today. Okay. And
Sir, I have a doubt.
yes.
The term which you always mention, that feature selection and feature engineering.
Hmm.
So selection we have done before, the pre-processing part which we have done. So
Yes.
feature engineering, this whole codes which you use
Feature
for.
engineering involves the dummy variable, creating a dummy variable.
Okay.
You know,
So
that is
this,
a part of feature engineering.
I see. So it doesn't involve imputation and outlier detection and all those stuff.
No, no.
Okay,
You know, that is a feature processing.
okay, okay,
That is a part of feature engineering basically. That is also outlier in the everything we do. It is a part of feature engineering basically. I have a script for that now. I just show you the data preparation you have attended na, or not.
yes,
In that I explained this in detail. I'll show you that. Or if you say, I will share with you. Look at this. Are you getting?
yes. But I haven't attended, I guess.
Yes. So this is the feature engineering. What
Okay,
is feature engineering? It's the process of using domain knowledge of the data to create features that make machine learning algorithm work.
okay,
And everything I have given. Why feature engineering is important, feature engineering, and what are the encoding techniques in the feature engineering. We are using the dummy variable technique. Okay.
okay,
There is the nominal, ordinal, one hot encoding, and then label encoding, frequency encoding, and proportion encoding, target encoding, it is also called. So this we do in the logistic regression, target encoding.
okay. So you will be sharing this as well.
Yes, yes.
Okay, okay, fine.
So tomorrow we have lots of discussion with these all assumptions. Okay. And I will explain you each and every concept of this normality of the error, what we get always. That should be normal, the residuals, whatever. Normality of the assumption that a variance of the error remains constant across the predictor values. So this I will explain these all things tomorrow. Okay. Okay. So now we wind up it. Okay. Thanks everyone.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.